Oh, well, hello, wonderful class. We're going to go over this nomenclature activity here. So, it says type 1 binary ionic compounds. It also will eventually talk about type 2, type 3. I thought it might be worth kind of reviewing what those things are. So on the periodic table, just to remind you, we go like this. We separate things like this. Just go down and around this little stair stepper. And then we say the stuff up here is nonmetal. And that includes helium and hydrogen, even if you've moved the helium over for electron configuration. And all this other stuff we say are metals. Right, nonmetals, they tend to gain electrons, metals lose electrons. So these nonmetals become negative, metals become positive. All right, so there were different kinds of ionic compounds. We used the charges in some of them, where we actually knew the charges. If you remember, the first column is 1 plus, second column is 2 plus, three columns 3 plus, 4 plus or minus, 3 minus, 2 minus, 1 minus, and 0. And if you want the theory behind that, you can go to older videos. All right, and remember, these charges do not apply down here. So they only apply to up here. But the metals that are like here and all the way over here, we don't know their charges, with the exception of a few. We know this little triangle right here. We know that these three will all be 3 plus, these two will be 2 plus, and this silver would be 1 plus. Okay, 3, 2, 1. And all of these other metals here, we do not know the charges of. Again, we know the first and second column as well. So first, second column, those things right there. Anytime you have a metal made out of, an ionic compound made out of ones that you know the charges of, we're going to go ahead and call that type 1. So type 1, you know the charge of the metal. So if I were to say like cadmium oxide, you'd look over here, you're like, cadmium. Oh yeah, I know cadmium. It's a 2 plus. And oxide's right here. It's a 2 negative. You would just need one of each. And Cadeau would be your answer. Okay, so this is a type 1 compound. Type 2 compounds, we don't know the charge of the metal. It has to be given to us or derived. So, for example, if I say copper 1 oxide, I didn't do a very good job. This Roman numeral should be attached to this copper because it's like, dude, this is copper 1. What this tells us is that copper here has a 1 plus charge. We wouldn't have otherwise known that because copper, again, is in this region where we don't know the charge. Oxide, again, is a 2 negative. I didn't go over that, but it's a 2 negative because it's in this column. Okay, so when we go to cancel them out, you'll see this has a positive and this has 2 negatives, so we actually need 2 coppers to cancel them out, and Cu2O would be copper 1 oxide. So type 2, this is when we use the Roman numerals. Then we get to something called type 3. Not too many places actually call them type 3. We normally call them covalent compounds or molecular. This is always just going to be 2 or more nonmetals. This is where you use those prefixes di, tri, tetra, etc. So for example, if you have N2O4, we don't even have to look at charges or anything when we're doing these because they're both 2 nonmetals. So you have an N and an O, they're both in the nonmetal section. And so this should just be dinitrogen. And you would normally write tetra oxide, but because you have 2 vowels together, they just call it tetroxide. Cool. Okay, so these are the 3 types that we're going to discuss in the lab today. All right, so the worksheet here starts off by giving you kind of an overview of the charges. Here's 1 plus, 2 plus. This should be 3 plus, 3 plus, 2 plus. and a 1 plus, so they kind of didn't do the whole triangle. But there, we fixed it. Now there's triangle. All right, something to consider. The charge should technically go after the number, but this worksheet was not done that way. So, but it was not something I would mark you off for. All right, type 1 binary ionic compounds. Okay, it says from the following list, cross out those compounds that do not belong in type 1. Remember, type 1, we know the charge of the metal. So essentially, we're just looking at this periodic table saying, what do we know the charge of? So the metal is always the thing that's starting with. So sodium right here, we do know its charge. Iron is right here. We do not know its charge. Calcium, second column, 2 plus. We know its charge. Titanium, somewhere in here, we don't know its charge. Magnesium, second column, we do know its charge. Aluminum, it's in our triangle, so we do know its charge. Potassium, we know its charge of. Potassium, we know its charge of. Beryllium, second column, we know its charge. Copper, we do not. Silver, we do. And zinc is right here in the triangle. We also know its charge. So we're going to eventually name these things on the next page, but before we do, let's answer these questions. What type of element is always listed first, metal or non-metal? So hopefully you agree it's always the metal, followed by the non-metal. So like sodium chloride, we always say sodium and then chloride. Is the name of the first element in the compound different from the element? Okay, so if we were to name this thing right here, which is again sodium chloride, we just say sodium, which is not different. And it says, what is a common ending for all these names? Ide, right? And zinc fluoride, there are 2 fluoride items. Are they indicated in the name? So for example, in zinc fluoride, I would use a zinc 2 plus and an F minus, and I would need 2 Fs in order to make it, and that'd be a ZnF2. This would be called zinc fluoride. So there are 2 fluoride atoms. Are they indicated in the name? No, you just called it zinc fluoride, right? You didn't say zinc difluoride or something like that. And it says, what is the charge on the zinc ion? Hopefully you agree it's 2 plus. And what is the charge on the fluoride ion? Hopefully it's 1 minus. Why do you need 1 zinc and 2 fluorides? Because they cancel. And why do you need 2 sodium ions for every sulfide ion and sodium sulfide? So kind of a random example, but sodium sulfide would be made out of an Na plus and an S2 minus. You would need 2 sodiums to cancel it out. So once again, it's to cancel. Now I'm writing less because I have a marker, but if you want to elaborate on that, you're welcome to. But just writing cancel is fine with me. All right, as a team, I guess it's just you and me, guys. As a team, determine the rules for naming type 1 binary compounds when given the formula. So I'll essentially just name the metal plus non-metal, and you end it in ide, right? As a team, determine the rules for writing the formula for type 1 binary compound when given the name. So if you're given the name, you find the metal charge, you find the non-metal charge, and multiply them to get them to cancel. Now, if I gave you these directions, there's no way you'd understand them, right? But there's not a lot given, and essentially I'm just looking to see if you understand a general idea of how to find these formulas. All right, moving on. Okay, oh sweet. Name each type 1 binary ionic compounds in question 1. All right, hopefully this is relatively straightforward. I'm going to throw them at the top here so you can see them. So on page 1 we had this one. Hopefully you agree that's sodium chloride. After that, we had this one, calcium chloride. This is magnesium and oxygen, So it's magnesium oxide. Here we have AlBr3, aluminum bromide. KCl. K is potassium. You guys need to know that for the exam for sure. Potassium chloride. K2S. Doesn't matter if there's more or less of them, it's still the same naming kind of system. Potassium sulfide. BeF2. Beryllium fluoride. We spell fluoride UOR. If you have flour, like the kind of flour that you eat for bread, that's fluoride, not fluoride. AgCl, silver. Ag is silver, and Cl is chloride. And last but not least, even though there's a bunch of different ones, 3 zincs and 2 nitrogens, this is just zinc and nitrogen, which we would call zinc nitride. All right, on to type 2 ionic compounds. To remind you, type 2 ionic compounds are the ones where we use the Roman numerals. All right, so from the following list, cross out the compounds that do not belong in the type 2. In other words, if we don't know the charge, just to remind you, if we did know the charge, they're type 1. So if we don't know the charge, all these white spaces right here, they're going to be type 2. So looking through it, aluminum, we know its charge, we'll cross it out. Iron, we do not, we keep it. Silver, it's a +1, it's in the triangle, we know it. Vanadium, keep it. Cobalt, keep it. Tin, keep it. Potassium, no. And I'm going to go back to tin real quick just to show you guys. Tin's here. It's really common. People look at it and they're like, oh, it's a 4+ charge. But it's under the stair stepper, therefore we do not know it. All right. Strontium. Oh, I almost messed up here, but I'll show you guys. Strontium's right here. It's in the second column. We do know its charge, and so I should be crossing it out. Copper we don't. Gold we don't. Zinc we do. Mercury we don't. All right, so looking at these, what type of element is always listed first, the metal or non-metal? Hopefully you agree it's the metal. And then second comes the non-metal. They're always, all these, iron, copper, manganese, etc., always metal first, then non-metal. What is the common ending for the metal portion, non-metal portion of the names? If you look, they all end in "ide." What, in the compound FeO, what is the charge on the iron? Okay, so if we have an FeO, an example sheet here. If we have some FeO, we know that oxygen is in the 6th column here. It's got a 2 negative charge. We know that we have 1 iron. So what must the charge of iron be to cancel the 2 negative? It has to be 2 positive. So this would be iron 2 oxide. Okay, so what was the charge? 2+. What about Fe2O3? Let's do Fe2O3, which is also known as rust. Here we have 3 oxygens, each one bringing 2 negative, so we have a total of 6 negative. But the iron here, we have 2 irons, and you know that those must add up to be 6 positive. So if they have to add up to be 6 positive, what does each iron have to therefore bring? Hopefully you agree it has to be a 3+ charge, because that's the only way you're going to get 6 positive. So it would be 3+ here. What does the Roman numeral after the metal name represent? The metal's charge. When the name ends in "ic", to what ion does it refer? We're not doing that. And we're not doing that. Those are old naming rules, and we just don't care anymore. Okay, so as a team, come up with rules for type 2 when given the formula. I'll just let you guys go ahead and do these 2 as well. As a team, blah, 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 blah. So do that. Let's go to the naming. That's what I care about. That's some more fun stuff. All right, so looking at these, we're just going to go ahead and name the ones that are up here. So it's going to take a little bit I'm gonna pull some more paper out. Because we have to figure out the charge on all of these, naming these things is a little harder than just listing the metal and the non-metal. Because again, we need the charge. So the first one is FeCl2. We know that there's 2 chlorides. Each one gives me a 2 negative. So therefore my iron must be 2 positive. So this must therefore be iron 2 chloride. We go to VBr5. Each bromide's in the 7th column, so each bromide brings us a total of -1. I could draw them all out, but hopefully you agreed times 5 would give us a -5. So therefore, what must this 1 vanadium be to cancel out the 5 negatives? Hopefully you agree it's a 5 positive. And that's why this would be vanadium 5 bromide. Vanadium 5 bromide. Moving on up, we got COS, just cause I want to do it. Hopefully you see S has a 2 negative, so cobalt must therefore be a 2 positive. This is cobalt 2 sulfide. All of them ending in "ide" because we're just taking one thing from the periodic table. Then we have SnF2. It's a sin if you don't know tin. Each fluoride brings us a -1 for a total of 2 negative. So then tin here must be 2 positive. And this would be tin 2 fluoride. Keeping going. The next one we have is this copper thing. We know bromide has -1, so copper therefore must be a +1. And this is copper 1 bromide. We get to this, AuCl3. Each chloride has a -1, so all of them together give me a 3 negative, meaning this gold must be 3 positive. This is gold 3 chloride. All right, last but not least, we got some hugs. If you remember Hg, we said mercury loves hugs. This is mercury, and this is a sulfide. Sulfide has a 2 negative charge, it's in the 6th column, so therefore mercury must have a 2 positive charge, and this is called mercury 2 sulfide. All right, hopefully that helped. That got us through, I think, type 2. And now we can move on to type 3. Surprise. Okay. So type 3 binary compounds. So it says from the list, cross out those that do not belong. Remember, when we talked about type 3 compounds, we were talking about the 2 or more non-metals. So if it's got a metal, that's when we use di, tri, tetra, etc. 2 or more non-metals. If it has a metal, it can't be a type 3. It must be a type 1 or type 2. So if it has a metal, it straight up just can't even be that. So let's go through this and essentially just cross out anything that has metals. So here we have carbon and 4 chlorides. Those are all non-metals, that's good. Here we have an aluminum, nope. Carbon and oxygen, okay. Selenium, 6 fluorides, okay. Silicon, 2 oxides, okay. Strontium, nope, that's in the 2nd column. Phosphorus, good. Titanium, nope. Selenium, okay. Iridium, okay. Zirconium, nope. Get rid of it. All right. So let's go ahead and name these. What did I say? Iridium? Sorry. No iridium, you guys. That's transition metal. All right. So which element is listed in the name first? So it's always going to be the first element that is drawn. Another thing that we learned from this week, and if you're in future classes that you might learn in the next week, is that it's the least electronegative element. So least EN element. Remember, electronegativity goes up and to the right. So whatever's the least electronegative is usually the one that's listed first, unless it's an acid. And the name, is the name of the first element different from the element? It depends. So this one is, for example, this is carbon tetrachloride. But over here, this is tetraphosphorus. So carbon tetrachloride, I say carbon the same way I would say carbon if I were just looking at it. But over here, I'd say tetraphosphorus as opposed to just phosphorus. So it has a prefix, right? But in general, the first name is still the same. So I'm just going to say yes. Next, it says, what is the common ending for all the names? Well, you can look. Carbon dioxide, iodine pentafluoride, dihydrogen monoxide, boron trifluoride. It looks like they're all still ending in "ide." What do the prefixes di, tri, penta, or di, mono, penta, and tri all mean? So di means 2 things, mono is 1 thing, penta is 5 things, and tri is 3 things. 2, 1, 5, 3. All right, is the prefix mono used when there's only 1 atom first? So if there's only 1 atom of the first, we don't call it monocarbon tetrachloride, we just call it carbon tetrachloride. And we talked about that in class. We said chemists really hate mono, and there's a reason for that. So no, you're never going to use mono as your prefix. Is the prefix mono used when there's 1 atom of the second element? Yes. Any other time we use mono. As a team, determine the rules. I'll leave it up to you. It's going to look something like prefix plus the name of one plus prefix plus the name of the other, ending in "ide." Something to that effect. All right, let's name them. So this first one, we have a carbon and 4 chlorines. So we would call this carbon. And then 4, we'd use tetra. And then chloride. Okay. Here we have a C and an O. We never start with mono. So this is carbon. But the O is a second element, so that's when we're going to use mono. So this is carbon monoxide. If you'd said carbon monoxide, I would not have taken points off for it. But again, when you have 2 vowels together, you generally want to squish them together. All right, this one, SEF6, looks like selenium hexafluoride. SiO2, silicon dioxide. P4O10, I need a space to write this, tetra phosphorus. Dec oxide. SeO3, selenium trioxide. Last but not least, N2O5, dinitrogen pentoxide. Okay, so compounds containing polyatomic ions. We need to know polyatomic ions. This is not the place to learn polyatomic ions. I'm just helping you go through this worksheet. We've gone over them several times in class at this point. So you should already pretty much have them memorized by the time you get to this sheet. However, if you don't, go back and watch the polyatomic ion video. So nitrate is NO3 negative, so NO2 negative must be nitrite. Oh, it's hydroxide. Cyanide. We know that's got the C and the N in there. Chlorite. Chlorate is ClO3. So ClO3 2 with a negative charge must be chlorite. This is the CHO part of nacho. This is acetate. This one right here, hopefully you remember it from day 1 of polyatomic ions, is chromate. Carbonate is CO3, 2 negative. Sulfate is SO4, 2 negative, so this SO3 must be sulfite. Right? Right. Okay. Moving on. Okay. So, ooh, good Lord. Match. What is the number of carbon elements, oxygen? Okay, no, I'm gonna go with the way that I taught you guys. That looks exhausting. It's really helpful if you want to use it for to learn like some unexpected polyatomic ions, but the ones that we've covered are sufficient. Okay. We talked in class about chlorite. We said if you take 1 away, it's chlorite. If you take 2 away, it's hypochlorite. Hypo means less. And if you add it, it's like hyperchlorate, but chemists don't like the hype, so we just call it perchlorate. Okay, so when comparing the oxyanions above, is the charge of the chlorite ion the same as all the others? So are they all the same? I hope you agree they all have a -1, so yes. How many less oxygen atoms does chlorite have compared to chlorate? Anytime you go from an 8 to an 8, it's just 1 less. How many more does perchlorate have compared to chlorate? Well, perchlorate has 4, chlorate has 3, so it's got 1 more. How many less does hypo have compared to chlorate? Hopefully you agree, it's 2 less. It goes from 3 down to 0 or 2. What ending can help you identify the presence of an oxy ion in the compound, of an oxyanion in the compound? It's going to be 8 or 8. So if something ends with 8 or 8, you're like, dude, polyatomic ion. If sulfate is this, what would sulfite be? We just had that question in the previous thing, and we decided it was SO3, 2 negative. Nothing else changes except for the number of atoms, oxygen atoms. Okay, we're getting there. We are getting there. All right, in the table below, fill in the oxyanions and then use the figures on the previous page. Okay. So if you have something with bromine, it essentially wants a per bromate anion. The bromate was BrO3, so per bromate would be BrO4 negative. Maybe let's do the 8s real quick, because that's probably where it wants us to start. That's why it's a different color. Iodine, IO3 negative. Phosphate is PO4 3 negative, and nitrate is NO3 negative. You should have these all memorized. Now we can maybe fill out the rest of the table. So bromate is this. Bromite must be BrO2 negative, and hypobromite is just Bro negative. Remember when we did NaBro? That's what it came from. Okay, iodine, we can have a per iodate ion, which would be IO4 negative. The 8 again is IO3. Ite would be IO2. And the hypoite would be IO. All right, phosphorus is PO4 3 negative. So, or phosphate, excuse me, is PO4 3 negative. Phosphite must be PO3 3 negative. Nitrate is NO3 negative. Nitrite must be NO2 negative. All right, on to the next part. So here, it wants us to fill in this table. This is pretty important stuff. I think I'm gonna, this is gonna be the main thing that I'm going to look at in grade, because it brings everything together. Yep, I think so. That's gonna be the main thing I'm gonna look at in this worksheet. You still have to complete the rest, but yeah. If I'm gonna go grade something, it'll probably be this. All right, check your work. Were the polyatomic ions correctly identified? Well, I'll let you know. You will let me know. So make sure all these things are true when you go fill out this table. Sweet, what have we got left? Acids, our favorite. Okay, acids are compounds that when dissolved in water, they give off that H+. Naming acids can be tricky. No, it isn't. You guys got this, right? Okay, anytime it's a simple acid, you use hydro. So if it's just something from the periodic table, we call it a hydroic acid. Anytime it's with an 8, we call it an ic acid. Anytime with its ite, it's an us acid. The only time, again, you use hydro, and we said that means simple. Okay, so let's go ahead and use that and answer some of these. Based on the 8 determination figures, what is the formula for nitrate? Is NO2 negative the nitrate or nitrite ion? Hopefully, you guys agree that that's nitrate, and therefore this must be the nitrite ion. According to the figure above, what must be added to create an acid, and what is the charge of the ion? Okay, so essentially they're trying to help you build an acid out of this thing. So according to the figure above, what must be added to create an acid? You have to add an H+ in order for it to give off an H+. So NO3 negative, we would add an H+, and it's got a charge of 1+. How many of the hydrogen atoms must be added to NO2 negative to make a neutral acid? Well, we don't worry about the fact that it's NO or 2, we just worry about the fact that it's a -1. If it's got a -1, how many positives do you need to add to cancel it out? Hopefully you agree it's just 1, and the answer is just 1. So what is the formula? HNO2. You have an H+, you have an NO2, and they just cancel each other out, the charges. Based on your answer to question 1, does the name of this end in ite or ate? It was ite. The NO2 was ite. And then use the figure above to determine how the name changes when we have compound HNO2. So in other words, name this acid. Okay, so we would normally name this acid, like when you kind of want to start with the idea that it's an acid that starts with an H. And then you're like, okay, it's an acid made out of nitrite, right? But nitrite is not the name of the acid. We take out the ite and we write us. This would be nitrous acid. Nitrous acid. Okay. Yeah, I think this would be the other table that I want to go ahead and look at and make sure that you guys have down. So focus on this table, focus on that table, and those will be the things that I'm looking for when I go to grade your experiment. All right, y'all, have a great day.